Okay, so if we're graphing a system of linear equality in two variables, first thing we're going to do is we're going to graph the boundary line for the inequality, use a dashed line for greater than or less than, use a solid line for less than or equal to or greater than or equal to. Then we need to test a point that is not on the boundary line to determine whether it is a solution of inequality. Then step 3, when the test point is a solution, shade the half plane that contains the point. When the test point is not a solution, shade the half plane that does not contain that point. Okay, well, let's just actually look at this here. Let's actually graph some of these here, and it's going to make more sense when we graph it. Now, the first one's a little bit challenging. It's y is less than or equal to 2. Well, since it's y is, if this was y equals 2, we're talking about a line that is, what, horizontal. Y equals is always horizontal. So we do this here. Well, y is 2 at the y-intercept of 2, and it's going to be a straight line going left and right. It's going to be a horizontal line. Now, the way we can do this here is we're going to draw this line going this way here. This one here is just y equals 2. It is a horizontal line and intersects at the point 2. Now, because it is equal to, y is less than or equal to 2, the line would be what? Solid or dashed? So would this line here be solid or dashed? It is solid if it's equal to. It is dashed if it is not. If it's just greater than or less than, then it is dashed. If it is equal to, then it is solid. Use a solid line for when it is greater than or equal to or less than or equal to. And we use a dashed line if it is just greater than or less than. So this one here is equal to, it would be solid. Now this one here, what we can do next is we can check a point. I am always going to pick the origin, as long as the origin is not a point on the line, because the x and y values at the origin are what? What are the x and y values at the origin? 0, 0. They're always 0, 0. It's an easy point to check. So if we plug that in for this here, well, there's no x spot, but there is a y. So 0 less than or equal to 2. Is that true? Well, yeah, 0 is less than or equal to 2, yes? If our checking point is true, we shade the side that contains that point. If it is false, we shade the other side of the line. And that is all we have to do for this here. So really, when we graph a linear inequality, this here is in one variable or in two variables, we graph the line, take a point to check, to plug in and check to see if it's a solution. If it is, we shade the side with that point. If it's not, we shade the side without that point. Because any point down here is going to be true. Because where's the point we checked?
Oh, so we're going to, but if it was greater than 2, then it would have been at top, right?
I think it's 0. I picked it. Because we need to check a point. So I need to check a point above it or below it. Now, say we pick the point, here, let's just pick 6, 0. Because we don't have an x value for this here, but the y value would be 6. Now, is 6 less than or equal to 2? Is 6 less? So this is false, yes? So we don't shade the side with that point because it is false. Those points would not be true.
So we wouldn't.
So we won't shade this side, we shade the side that doesn't contain that point, because any point in this area would make it true. Questions on this here? Because like we talked about yesterday, if it's in the shaded region, it makes the statement true. It's any point in that area that will make it true. So let's look at another one. Y is greater than or equal to -3. Now again, y equals or x equals will have a straight line, either horizontal or vertical. It's either be going up and down or left or right. Now y equals -3. Well, the point -3, it will intersect the y-axis at -3. And it's going to be going to the left and to the right. It's going to be horizontal. We'll have this here. Now, should this line be solid or dashed? Solid because it is equal to, we have greater than or equal to. If we have greater than or equal to or less than or equal to, it will be solid. Okay? So, give me a point.
I'm like really confused on what we're trying to teach us, right? Because it seems like we're plotting a point and then plotting another point and then just shading it.
Well, we're graphing systems of linear inequalities. So here, to graph a linear inequality, well, we need a starting point. These here, I don't like these too much, these y equals, x equals, because it ends up being just a straight line, one of these two directions. Because at this point, really, y equals -3. It's just a straight line at -3. There's not too much to that. Now, what we're really doing is first graphing the line. Now, we're kind of referencing back to y equals mx plus b, but the m is, we don't have this, so it's really y equals, b is the line we're graphing. So we're graphing the line y equals -3, because the slope is 0, it doesn't rise or, it doesn't go up or down. Now, since it's an inequality, it can be greater than or less than it. So it can either be above the line or below it. Now, we need to figure out which side it is, so I'm going to pick a point to be able to check it. See, which side do we need to shade? So give me a point. So we can always do 0, 0. I like 0, 0 because it's easy to check. So since we don't have an x in this here, we plug 0 in for y, and is 0 greater than or equal to -3? So we shade the side with that point. If it was false, or just one. Because if it's true, we shade the side with it. If it's false, we shade the side that doesn't. Mm-hmm. Yeah, we can always choose that, but sometimes, especially when we start talking and looking at linear equations where it's not just straight up and down or straight left and right, where we have y equals something else with x, I like 0, 0 because no matter what the number is with x and y, it'll always work out to be 0. And it'll make a little more sense when we actually see something. Okay, I want to get to this here. Because this here is actually going to make these make a little more sense when we're not looking at just lines that are straight up and down. So we're looking at number 1. Yeah. Yeah. Mm-hmm. Yeah, and I can look back at it. Now, this here is going to make a little bit more sense. We'll work with this here, and we'll come across some with dashed lines. is we want to graph this line. Now, it's already y by itself, so y equals mx plus b. We can treat it the same as graphing a line. So the 3 here is our slope, and the 4 is our y-intercept. Yes, sir? Yes. So it'd be a straight line like this here. And then we would end up shading this side over here. Because if we check the point 0, 0, well, 0 less than or equal to negative 4. No. So this point is false, so we shade the side without it, which would be that side over there. Does that make sense? Okay. Now, looking at this here, with any of these here, the first main step is to graph the line. Now, y is less or greater than or equal to negative 3x plus 4. Well, our slope is negative 3, and our y-intercept is 4. So where are we going to start? On the 4. Now, our slope is negative 3, so what does that tell us? And to the, so I go down 1, 2, 3, and over 1 to the right. Now, we can do this again. I can go down 1, 2, 3, and over 1 to the right to make the line. 1, 2, 3, and over 1. Now, is the line going to be solid or dashed? Because it's equal to, the line is going to be solid. Because anytime we have equal to, it will always be solid. So we have this line here. Now we need to check a point. We need to check a point to see if it is true or false. Because if the point is true, we shade on the side with the point. If it is false, we shade on the side without that point. So what point should we check? Negative 5. Negative 5 just here or any? Between x and y. I'm going to check 0, 0. But just give me another point somewhere over here. Negative 5 what? Yeah. Negative 5, negative 3. So we can check this point here. And I also heard 0, 0. We can check that point as well. So let's start off with checking negative 5, negative 3. So if we check that there, and y is greater than or equal to negative 3x plus 4, if I plug in negative 5, negative 3, let's see what we get. Well, I'd plug negative 3 in for y, so we'd have negative 3 is greater than or equal to negative 3 times negative 5 plus 4. Well, negative 3 times negative 5, the negative and negative would make a. So this would be 3 times 5, which is. Now 15 plus 4 is 19. Is negative 3 greater than or equal to 19? What do y'all think? It's false. So it doesn't work, so that means we don't shade. So this doesn't work, we don't shade on this side, we shade on the other side. And that's it. Questions on this here? Okay. Okay. Now, what I was also going to look at is, because we also had 0, 0 that we could check, because we can do that one as well. If I plug 0, 0 in, 0 is less than or equal to negative 3 times 0 plus 4. Well, what is negative 3 times 0? 0. So this is gone. So I have 0 is less than or equal to 4. Is that true? Well, no, it's still not true. So we would still shade the same side. This is why I kind of use 0, 0 as long as it's not on the line.
How'd you get that other point? Or did you just choose?
We just picked one. Yeah, so the point we checked is completely arbitrary. We are just arbitrarily picking a point that's not on the line. Because any point on the line, any point on this line here, will make both sides be the same. So it really doesn't tell us anything.
Wait, so if the point is on the line, it can go either way?
So here, 1, 1, if we check it, it'd be 1 is greater than or equal to negative 3 times 1 plus 4. Well, negative 3 times 1 is?
So that it's true. It's on 1.
Right. And if this was a dashed, if it was just greater than, well,
Like, that would be false.
right, but it's a dashed on the line. But it's not really telling us which side is shaded.
So it'd still be wrong, right?
Right, it'd still be wrong, and with it being dashed, those points aren't included. So we need a point off of the line. So it's telling us, like here, 0, 0 didn't work. So any of the points on that side of the line will not work. It's going to be on the... So we need a point off the line. So as long as 0, 0, I like this point. As long as it's not on the line, I use it because, well, anything multiplied with x, anything multiplied with y now becomes 0, and we're just simplifying down.
So, if it's on the line, like, it goes either way.
Yeah. Yeah, once it's on the line, it doesn't tell us anything. So we have to pick a point off the line. Okay, let's look at this one here. Y is less than or equal to 3/5 x minus 5. So again, this is going back to our y equals mx plus b. It's going to tell us that the slope is 3/5 and the y-intercept is negative 5. So how are we going to start graphing this line? How are we going to start graphing this here?
-5.
We're going to start at the negative 5. Because negative 5 is the y-intercept. Is where it crosses the y-axis. So we go up 3 and over 1, 2, 3, 4, 5. And again, our slope, we didn't mention this earlier, but it is rise over run. So the top number is how far it goes up or down. The bottom number is how far it goes left or right. So we go up 3 and over 5, and well, we can't really go any further than this because it kind of goes off the graph. Yes?
Yeah.
Now, would the line be solid or dashed?
It'd be solid. Yeah, I think so. It's y-intercept.
Yes. You got 4 minutes as well. Because slope tells us how far it's going to go up and to the left or right, or how far it's going to go up or down, left and right. And B gives us the y-intercept where it crosses the y-axis. And whenever we're graphing a line, we always need 2 points. I need 2 points to be able to graph a line. Well, y-intercept, where it crosses the y-axis, gives me 1 point. And if I can use the slope, rise over run, I can find the second point. So if it's in y equals mx plus b form, this form here, I can use rise, the slope, and the y-intercept to find the overall graph. Does that make sense? So the y-intercept is always going to be right here on the y-axis up and down. Since it's negative 5, we go down to negative 5. That's because the number is positive. We have a positive 3/5. We're going to go over and Right. It should always, since it's positive, it should be increasing as we read it from left to right. If it's negative, it should be decreasing from left to right. Well, that leaves us with what? We need to shade. But in order to shade, we need to check a point. What would be a good point to check? 5, 3. We can check 5, 3. And we're going to plug this into our y is less than or equal to 3/5 x minus 5. So we'll plug 3 in for y, 3/5, and we plug 5 in for x here. Now we can do this all by hand if we wanted to, or we can actually type 3/5 times 5 minus 5 into the calculator. We can plug that whole side in.
Why don't you just stick to
We had one picked. I would pick 0, 0, but yeah, it'd be a little bit easier. Because here, if we do this multiplication, these would simplify, and we get 3 minus 5. And 3 minus 5 is negative 2. Is 3 greater than or equal to negative 2? No. So we shade the points below the line. If it's true, we shade the side with the point.
Okay, and then if it's
False, we shade the side without it. So it's almost, if it's true, we shade towards the point. If it's false, we shade away. So if it's true, we're shading towards the point. If it's false, we're shading away from the point. Now we could have tried 0, 0, because I think some of y'all were saying that also. No, can't do that. So if we did 0, 0, I'd plug in 0 for x and y. That would become 0, and 0 is still not greater than or equal to negative, or less than or equal to negative 5. So it still works out. Questions on this here? Are you good with this here? Yes. Okay. I want to change this up a little bit. And I want to change it from greater than or equal to just greater than, because we haven't come across a non-equals equation yet. Now, the difference between this and what we would do for an equality, what it is equal to, isn't going to change that much. It's only going to be slightly different. Now, it's still in y equals mx plus b form. The slope is 7/4, and our y-intercept is 2. And the 2 is positive. So we need 2 points to graph a line. Where can we start? On the y-axis. Because the y-axis is positive 2, it's going to cross the y-axis at 2. So we make our point. Now the slope is 7/4. Right, because we run out of room. 1, 2, 3, 4, 5, 6, 7. We're out of room. But I can go which direction? 1, 2, 3, 4, 5, 6, 7. Yes, 1, 2, 3, 4. Because if I go up and right, that's positive and positive, which is fine. But since I went down 4, that's negative, I need to go to the left. Because if I connect these 2 points, is the line increasing from right to left? Is it going up as we read it from, sorry, not right to left to right? As we go from left to right, is it going up? So yes, isn't it? It's increasing, so it does have a positive slope. So that's another way we can make sure we graphed it right. Because it should be going up. Now, is the line solid or dashed? It's dashed because it's not equal to, correct? Not equal to would be dash. Well, we all just drew a solid line, didn't we? Well, luckily, we have what? We have erasers, yes? Now we have a dash line. So you can go through and make a dash line by picking your pen or pencil up and doing it that way. Or heck, if you have a pencil, flip it over, and I can turn a solid line into a dash line by just erasing a few points along the line. Now we need to check a point. What point do we want to check? 0, 0. So if we plug 0, 0 in, 0 is greater than 7/4 x times 0. Well, that's 0. So the only thing we have left is 2, because that is 0. And 0 plus 2 is just 2. Is 0 greater than 2? Which one's bigger, 0 or 2?
So whichever one is like, see, that's the thing. The shading part is where I get.
No, Lily. See, mark the point 0, 0, and it's false. So it's on the other side of the line. The point 0, 0.
Because if you remember back to yesterday, because when we were plotting the points, because if the point was in the shaded area, it was true, yes? Because if our point was in the shaded area, it made the statement true. If it wasn't in the shaded area, it made it false, yes? So if I come up with a false statement, it means it's not in the shaded region. It means the other side of the line has to be shaded. So that's why we're picking a point and testing it, because if it's true, that area is shaded. If it's false, it's going the other direction. Or we're shading towards the point that's true. Well, if it's false, we've got to shade the other way. Questions on this here? Okay. Now, this here is where we're going to stop because our next set is not in a linear y equals mx plus b form. And we will do these tomorrow. These are in standard form. But the main difference between these and the other ones is just how we graph the line. Because again, to graph a line, we need how many points? 2. And there's a specific way that we get the 2 points for this here that makes it easier to work with. And they're going to revolve around 0.